Here we have with us piezoelectric sensors that are connected to give us AC output. The AC output is then connected to the bridge rectifier, which converts it to a DC output. Here we have an LED to check the light which will glow in case of the DC output. The output that comes out of it is connected to a milliammeter and a DSO to check the voltage and the currents respectively. When unpressed, we can see that the answer is 0, and on applying pressure, we see that the piezoelectric sensors generate certain amount of current and certain amount of voltage that will be used to convert current and voltage into the form of energy that can be used to charge our phones. The piezoelectric circuit is transferred to the sole of a shoe that would be used to generate the desired output. As we see here, we try to apply pressure on the sensors to get the desired output, and we imitate the walk of a person by applying pressure and pause in relevant amount to try and get the high and low output that would be received by a person when he or she decides to walk and use our model. And this could be used to charge a mini power bank or the phone respectively. Here we have the solar panel that is kept under direct sunlight, which is input. That input is connected to the DSO through wires, and the output is in the form of voltage of about 6.6 volts, which could be used to charge our phones or our mini power banks. And this solar panel module has been attached to our product that would give certain amount of output to our customers. Here we have a big DC motor which normally accepts 230 volts, but here we give it a supply of 30 volts plus VCC and minus 30 volts to minus VCC, and as the voltage increases, the speed of the rotation increases. We use this to replicate the moving wheel of a bike, and we keep the smaller DC motor closer to the wheel's rim to provide torque. We see that the mechanical energy gets converted into electrical energy, and we get an output of about 3.4 volts. We also notice that this is a very good source of current, and the normal current rating of 200 milliamps that is required is exceeded a lot more, and we get an output of close to 400 milliamps, and we see that the charging happens to be much faster by using this module. In this we can see that the phone when placed on a wireless transfer module, which is made up of the chip and the charging pad, charge our phone due to the power input that it has received from the mini power bank. In this we can see our mini power bank that is made up of lithium-ion rechargeable battery to form the main power bank, and the power management circuit that has two ports. The output USB male port is for charging the phone, and the input is to charge the main power bank, the one that is placed near the LED.
Is it here?
After verifying the required results and the desired output, we moved our circuits onto the PCB for the final compilation into a product that would be sold to our customers.
So these are the electrodes. This is the negative, and this is the other one is positive. Both are going to the block, which consists of the PCB design which we soldered in the previous section, and this also includes the input from the piezo, which is rectified and then given it to the box which has PCB. Initially it looks huge, but it won't after the design it won't be so huge. It comprises of instrumentation amplifier, high pass filter, low pass filter, then the rectification of EMG signal, and we also saw that the piezoelectric is also rectified. So both the inputs are given to the summer circuit, which is then boosted using the current booster circuit, and then the final output is obtained via this black cable connected, which in turn is connected to the mini power bank, which can be used later for charging main power bank. Similarly, dynamo is also directly connected to the main power bank because it has a high output current which is enough to charge the main mini power bank. This is our main power bank. It has solar panel on the top and below it has Qi charger for wireless power transfer or wireless charging. And it has two ports, one from the wireless charger which is always connected so that you can charge it wirelessly. If not, you can remove it. And also the solar panel also has a charger which is connected to the main power bank, the four lithium batteries which gets charged due to the solar panel. Now the output can be taken using this white wire which you can see. This gives the direct charge of 5 volts constant and 1 amps current, which is enough to charge a Android phone.